Find all the solutions of 2 cos 2 theta equals 1 minus 2 sine 2 theta between theta from 0 to 360. So let's have a look at this here then. So the cos 2 theta we can replace is cos squared minus sine squared, which is 2 cos squared minus 1, isn't it? And if we put that in, or 1 minus 2 sine squared, because then we'll have a quadratic in sine, won't we? So let's use the 1 minus 2 sine squared version for the cosine double angle. So here, 2 lots of 1 minus 2 sine squared theta then, that's our cos 2 theta, is equal to 1 minus 2 sine theta. So what have we got here then? We've got 2 minus 4 sine squared on the left when we expand the bracket. 2 of these minus 4 of these equals 1 minus 2 sine theta. Now let's move everything over to the right hand side. Move this over, we get 4 sine squared theta. I'm writing it down from right to left. The minus 2 sine theta is already there. And then move the 2 over. 1 minus 2 is minus 1. There's nothing left over this side, so it equals 0. And I've written it down from right to left, haven't I? So here, this doesn't factorize. You can try it. You can try a 4 and a 1. And it has to be 1 and 1. And any combination of 4 of these and 1 of these isn't going to give you minus 2. And the same goes for 2 and 2. Any combination of 2 1s and 2 1s will not correspond to minus 2. So we have to use the formula here then. So let's have a go at that. So sine theta then, quadratic in sine theta, is equal to minus b, there's b, so it's minus minus 2, which is plus 2, plus or minus the square root of b squared is minus 2 squared, which is 4, minus 4 times a, which is 4, times c, which is minus 1, and I'll put that as a plus now, all over 2a. A is 4. So that's equal to then 2 plus or minus 4 4s is 16 plus 4 is 20, so it's root 20 over 8. Now we just need the decimals here because we're just working out a value of theta, aren't we, for calculation purposes. So it's bracket 2 plus the square root of 20, close, get out of the square root and then close the bracket, divided by 8 equals, and then we get the decimal. Now it's 809, isn't it, to 3dp, 0.809, that will suffice hopefully. So it's equal to 0.809, and let's work out the other value. So the other value will be 2 minus root 20, won't it, divided by 8. So just change that to a minus. And it's minus 0.309, isn't it, to 3dp. Minus 0.309. So sine theta is equal to 0.809, or sine theta is equal to minus 0.309. So let's work out these then. This one first then. Draw a circle. Right, cast. Sine is positive in this example here, and it's positive here and here. Draw 2 lines to the horizontal, mark off the associated acute angle to the horizontal, and simply write sine alpha is 0.809. Shift sign of that value. So shift sign 0.809 equals. Now we're in radians mode. I want to change modes to degrees. So shift mode, and I want to go over to degrees because we're doing from 0 to 360, aren't we? 53.99, so that's going to be 54 degrees. So I'm going to stick to the nearest degree. Okay, so our first solution then for theta will be round to here between 0 and 360. So that's round alpha, which is 54 degrees. 54 degrees. And the other solution here is round to here, which is basically round 180 back 54, which is 126 degrees. 180 minus 54, 126 degrees. Let's do the next one now. Again, we just draw a circle. Sine is positive here and here, but sine is negative, so it's there and there. two lines, mark off the alpha again, associated acute angle, simply write sine alpha and drop the negative if there is one to drop. So now we can do shift sine of 0.309. So shift sine of 0.309. So let's put a 3 in there. 17.998, so that's going to be 18 degrees to the nearest degree, isn't it? 18 degrees. So theta is equal to then, the first solution is round to here, which is 180 plus 18, 198 degrees, and the second solution is right round to here, round 360, back 18, which is 342 degrees, 360 minus 18. So there's our four solutions.